Hello everyone, welcome back to the 8.7. And then today what we're going to talk about is Leslie matrices and restocking matrices recurrence relation. So start with some questions with the recurrence relation with curling and restocking. Um, so if we have a health center and then lifting and cycle fitness, so we have 80% people clients who attend to the lifting class in 1 week, and then they will attend to the lifting class next week again. And 20% which is moved to the cycle class next week. So 70% attend to the cycle class, and then 30% going to the next week to the lifting. So this is the transition matrix with the lifting and the cycling. And also what we have is the numbers also affect the people join the living both two additional people and three additional people join the cycle and two is lifting. So that's called the restocking or curling. That's the people adding for each week. Basically, are you going to adding the same numbers by each week? So we have initial state matrices as well. So which is 55 people attend to the lifting and 62 people attend to the cycling. So that will be your initial state grade. And then you're going to set up the reconciliation to find a week 2. So S1 means week 1. So once you're down that, and you're using the transition matrices and then to adding the additional matrices, and you are getting the answer for each lifting and cycling by CAS calculator. Then S2 will be your next one. So you're just using the CAS calculator to find your other answer as well. So then the solution that's showing in the CAS is just substitution into your numbers what we had. Another kind of question is like a weather questions. So normally we have something is like long run data to find out 75% chance today is dry, next day will be dry. 72% chance will be next day is wet and this day is wet. So calculate the rain for 3 days. Initially day is dry. So what we do is they give you the table that was the transition matrix and calculate the long-term probability initial day. Sorry, it's 3 days initial day is dry. So what we do is we're gonna find out the dry day and wet day. So if you say you want to find the wet day, for example, if you find dry day, the dry will be 1, the wet will be 0. So that's how you try to figure out when they're gonna be dry and wet. Secondly, if you have that, you're gonna try to find out 3 days, which is if we're using the in recurrence relation to find the next 3 days straight away. So which is translation to the power cubic multiplied by the initial state grade. And then you will find the probability. And for 57 or 58% chance gonna be a wet day, 42% will be the dry day. Then long term, which is you're gonna adding the large number for your n numbers, which is the terms are going higher. So once the terms are going higher, then the day will be wet, and the initial day is wet. So once the initial day is wet, so which is what we do is your S1 become to 0 and 1. So then you multiply by t to the power 0. So now what we do is you're gonna try to figure out how long gonna be using as. So now we do, let's try that real quick. So we say 0 and 1 and control variable we say g. So now what we do is c to the power 40 multiplied by g. So control equal, so you can say 47% chance will be wet. So that's how you find out the 47. Why am I writing 42? Just 47% chance gonna be wet. So now What we're gonna do next part is the lastly matrices. So lastly matrices, which is a square matrices, you don't have to follow up the column adding all together equal to 1. As always, you don't have to follow that part. So what you need to do is um, you really need to figure out is what's your initial state rate, and also lastly how to write the lastly. Um, so for this question, I will start with maybe um, this one. So if I study the breeding life cycle, so which is hens, and we have a chicken lay eggs and the adults. So start with start with the lastly matrix. Start with initial state, right? You have no adults, 20 eggs, and 15 chicken. So eggs will be 20, chicken will be 15, and no adults. So lastly matrix, which is we start with eggs, chicken, and adults. So if we get the lastly matrices, so what we do is we're gonna start with 550 eggs in the lifetime, which is producing the eggs. So which is adults to eggs will be 550, and then you cannot go into adults to chicken, so you cannot go in reverse, reducing or reverse. So that's why it's 550 and 00. Secondly, what we have for next part is we have the 72% eggs surviving the chicken. So which is 72 is from eggs to chicken. So that's why it's 0.72 in front. And 0 to eggs and 0 to adults. And 55 chickens survive to the adults, which is chicken to the adults will be 0.55. So this is lastly images, and then now we're going to find 4 circles. So which is we're going to last to the paracortic multiplied by the initial state matrices. And you can say no x, and then but they have 3,136 chicken, and adults will be 1,797 adults chicken. So that's the lastly matrices. So you can see you don't have to adding all together equal to 1. So that's how all the lastly works. Exam question. This is all transition matrices. Exam question. Hopefully, you can pause. Feel free to pause it and then have a look at the question, and especially question 2 as well. 32% chance. Friday same weeks and the closest to. Question 3 is the networks, and then what we do is we're going to transition diagrams is, and then you're going to try to figure out which actually the correct answer for you. So hopefully that all can practice with your revision of transition matrix. If there's any questions, let me know. And then this is all the matrix topic. And good luck on your SAC. And I'll see you guys in next chapter.